This is my Module 5 Mastery assignment. Topic 1 is using integrals to calculate area. A definite integral is the net signed area bound by a function and the x-axis. An antiderivative is a function that differentiates to another function. The fundamental theorem of calculus are the rules that link together a function and its derivative or a function and its antiderivative. Area is the measure of space, but in a bounded region, area is always a positive number. My example is to find the area bounded by f of x equals x squared minus 1 and the x-axis on the region 0 to 2. First, you must graph the equation, and we can see that there is area signed positive and area signed negative, but area is always positive, so we need to put some absolute value bars in the equation. We know the area under the x-axis from 0 to 1 is negative, so we must place this in absolute value bars. And then we add this to the area from 1 to 2, and this doesn't need to be placed in absolute value bars because it's already positive area. Next, we must integrate, so we get x squared minus 1 is equal to x to the third over 3 minus x for both these equations. But we're going from different values. The first one's from 0 to 1 and the second's from 1 to 2. So we solve by plugging in these values, and then we get that the area is equal to 2. We must remember to use the absolute value bars so we get a positive area. My second topic is volumes by known cross-sections. Cross-sections are the infinitely thin slices of volume, each of which represents a common geometric shape. Volume is the amount of space an object takes up. For each shape, we have a simple formula that we need to remember. These are the areas for each of the shapes. All we need to know is the value for g. However, to make it easier, the first 4 shapes, you simply have to square g, and then you multiply g squared by a coefficient, so the coefficients are below. The example is to find the volume using square cross-sections perpendicular to the x-axis with a base that is the region bounded by the function y equals the square root of x and the x-axis and the vertical line x equals 4. We must first envision the cross-sections, and to do this we place the side of the square in the coordinate plane so that the square is coming directly out of the plane towards the viewer. In reality, there will be a number of adjacent squares to create an accurate volume because we need an infinite amount, but these representative shapes give us a good enough viewpoint. Now we must solve the integral, and we know it's from 0 to 4, and the equation was the square root of x, and so we square this and it just turns into x. So it's the integral from 0 to 4 x dx. This integrates to 1/2 x squared from 0 to 4, and we just plug in those values and we get 8. This means that in conclusion, the volume using square cross sections of this region is 8.